Good day, I'm Renel German, and for this video I will explain the connecting of components for battery monitoring circuit and dark detector circuit using 505 time. So first, we will connect the supply voltage to the breadboard for battery monitoring circuit. For positive wirings, we will change the wire to red, and for the negative wirings, we'll change it to black. So let's just connect wire to the other side of breadboard. So this power supply, we will set it as uh, this will be the battery representation for the battery that will be test. Okay. So next is to connect the 4 LEDs to the ground, the cathode. Let's change the color of wirings to color blue. And next is to connect the 4 amplifier integrated circuits, the pin 7 to the supply voltage, to the positive. So let's just do it to the other op amps. So next is, of course, we will connect also the potentiometer to the ground, and to the supply, to the positive terminal also. Let's just do this to other potentiometer. So as you can see, I am changing the color of wirings depending on its terminal, where if it's positive or negative. So for the connectors of IC to the LED, each pin number 6 or the out, we will connect it to each of the LED. So this will determine if the charge, if a battery has a charge. So later on we will test it. And for the second output, all throughout to the second op amp. And for the last one, we just connect it again to the pin number 6 of the last IC. So next, from the wiper of each potentiometer, we will connect each pin, or we will connect a wire from wiper to each of pin number 2 of the 4 ICs. So we will connect it. So this is the first. For the second potentiometer, by the way, the value of each potentiometer is equivalent to 10k ohms. So let's just do this to the other remaining IC. And for the last, so the next is from each of the third pin of each IC, we will connect it to the supply voltage that we will test if it is discharge or charge. So we'll just so to identify this wiring, we will change it to orange. For the third, and for the last, So next we will connect a wiring from the fourth, fourth pin or the ground pin to the breadboard. So we will change it to black. And for the last, so next we will connect this orange wirings from the third pin of each op amp IC to the supply voltage that we will be testing. And we will just connect a ground wiring from this resistor, and that's it for the battery monitoring circuit. Now we will test it. Okay, so now we will test the battery monitoring circuit if it is working. So this potentiometer will identify if the voltage that we will going to test, the voltage of the battery or the voltage or the power source that we will going to test is fully charged. So as you can see, this LED light up, and therefore the other LED must light up also, since for this LED it will identify if the voltage is greater than 7 volts but less than 8 volts. Okay, so as you can see, it worked. So meaning the voltage of the supply that we test is fully charged. So now we will proceed to the other circuit that we will be joining together with the battery monitoring circuit, which is the dark detector circuit using 555 timer and light dependent resistor. So basically for this dark detector circuit, the 555 timer will act as a stable mode, meaning it will produce square waves, and we will just add photoresistor to come up with that mode. So first, of course, we will connect supply voltage from here. Okay, again, we will change the color according to its polarity. If it's red, we will change it to positive. If it is positive, we will change it to red. And for negative, we'll change to black. So next, we will connect wire to the other side of red. So next, connect all the positive terminal from each of the components to the VCC and the negative terminal to the ground. So here we will connect a wire from negative of the photoresistor to the resistor and will act as a pull down resistor. So we'll just connect ground wire for this capacitor. So for the 5-volt timer, we will connect the pin 8 to the VCC and the reset button to VCC also. We will also connect the ground pin or the pin 1 to the ground. And also for the LED, we will connect a wire to the ground. And for the ceramic capacitor also. So next, we will connect a wire from the third pin or the output to the LED and the control voltage to the capacitor, the ceramic capacitor. And next, we will connect the pin 6 and 7 in between of the positive terminal of polarized capacitor and to this 47 kilo ohms and we will also connect a wire from between this photoresistor to the negative terminal of the polarized capacitor. So next, we will connect the trigger or the pin 2 to the positive terminal of capacitor also. So basically, this dark detector circuit will work so how this dark detector circuit works is when there is no light, of course the LED will light up. It's because the 555 timer IC works as an unstable mode. So if you will drag this, it represents that the photoresistor receives light, so the LED will turn off. So when the photoresistor receives light, it will increase its conductance or the resistance. And as a result, this will turn off the LED. Okay, we will so as you can see the LED works. There's the LED light up because we set the photoresistor to no light. Again, the photoresistor receives light, so the LED turn off. So that's how the battery monitoring circuit with dark detector circuit using 505 timer work as a one circuit. That's all, thank you.